Hello everyone and welcome to Python programming series part 8, and as the title says, so this is an introduction to machine learning. Those who are very new to machine learning, so this session will be very much useful. This is the theoretical session. The first thing is I'm extremely sorry for not uploading video for a long time. It's almost more than a month I did not upload any video. So from now onwards, I will try to upload at least one video a week. So this is Ram Prasad Pujari, and let's dive into the session. So why should I learn machine learning? As you know that AI and machine learning, these are the two buzzwords we get to hear every now and then. And AI and machine learning are the growing field, the rapidly growing field, I can say, during the last few years. So this has an application in banking sector or logistics, e-commerce, including healthcare sector, agriculture sector. So everywhere this has an application. If you look at the market forecast, of course, I will not be spending much time on this. So you can see that the market share is growing exponentially during the last 10 years. This is projected 2029. It's expected market share is expected around $209.9 billion. All the companies are investing huge amount. Not only countries, not only companies, even the countries are investing huge amount in building infrastructure for AI, and identified some critical sectors where AI is being to be implemented. Now when you look at I'm going to just talk about two countries here. One is India, and you can see that AI market in India can be worth USD 7.8 billion by 2025. This is as per India Today news. So this is the UAE National Strategy for Artificial Intelligence 2031, and the few sectors, including transport sector, they have been identified, and AI is being used. And UAE also has a dedicated minister for artificial intelligence. Top companies. So we know that any company that doesn't use AI will be left behind. All the top companies make use of AI and ML, machine learning. As you can see here, I have listed few of them, like Tesla uses AI in autonomous cars, and similarly Google has developed its own framework called as TensorFlow. Amazon and Google, they also provide web-based services, the cloud-based services. And Amazon uses AI for customer sentiment analysis to analyze the feedback it receives from the customers and respond to the customers. Depends on the feedback, whether negative feedback or positive feedback, how to respond. Content moderation by Facebook. Facebook also has developed its own AI framework. Baidu is the top Chinese company which provides web-based services on AI. And so I have listed few of the products where AI is used by Google, like Google Photos, Google Translate, where it uses natural language processing algorithm. TensorFlow is a framework developed by Google, and this has been outsourced. And some other companies make use of these frameworks to build their models, their AI algorithms. AI or ML is also being used in healthcare sectors. Why AI sees rapid development during the last few years? So that is clear from this slide. So though there were publications happened on AI during 1950s, because it demands large computing power and it requires lots of data, especially when machine learning approach is used for training, and the machines are required with higher speed, better algorithms are required. So now we have all of this. Because of this, there is a rapid development in this area. So these are some of the definitions I found for machine learning. So deep learning is again a subset of machine learning. So where deep learning makes use of neural network architecture for learning from the data. So since it is deep learning is a subset of machine learning, again it requires a lots of data or examples so that it can learn from the data and then take decisions. Now, in order to give a difference between what is traditional algorithm and a machine learning algorithm. So in a traditional algorithm, so where there is no learning happening, where there is no training phase, you can see that in order to detect whether the image has a bird in it, that for example mako is a type of parrot, so whether this bird is there in the image. So what we do is we write a set of rules here, the set of rules to describe the features. So and based on that the decision will be made. So there is no learning. We don't have to provide examples. We don't have to provide a lots of data in this case. Whereas in the case of machine learning, what happens, rather than putting a set of rules, so we have an algorithm which is being trained by providing examples. So if you take an example of a cat detector to detect whether the image has a cat in it, so what we do is, rather than setting a rule, rather than writing a set of rules here, so we provide examples of cat images, a different image, thousands of examples are provided here, and so your machine is being trained here. So once it is trained, that is a training phase. So now it can perform prediction on maybe a new cat image, the new image which it has not seen during the training. So there is a training phase and there is a test or a prediction phase. Okay, so now performance of this particular model, that depends on two things. One is the algorithm that you choose. The second thing, the quality of the data that you have, how well you have trained or what kind of data you have provided. So both are very, very important here. Now, since we discussed about data, we want to understand what exactly is data. So because machine learning is all about learning from the data. So we want to understand what are these data sets and what are these examples. Now, type of data set depends on the application. So we cannot have a same data set for every application or use case. In this particular slide, I'm showing one type of data set or one type of example that is provided to a machine for learning. This data set is provided for house price prediction at a given location, and this is a very simple data set. If you look at this, for house price prediction, at least one feature or one input is required. That is the area of the house. As you can see, area of the house and price are related to each other. So area is the input, price is the output. But normally when you're in a data set, we say this is the feature and this will be the output variable. So this is the input variable, which is nothing but independent variable, we say, and this is the target variable or output variable. It's also called as a label, or it's also called as it's a target variable or dependent variable. So each row is an example here, which is input 2104 and $400,000, that is the price. If area is 2,104 square feet, then the house price will be $400,000. So this will be one example. So thousands of such examples, thousands of rows, I can say, will be provided during the training phase. Now, this is a very simple data set, but when you talk about real world examples, It is not enough if you provide only one feature, like a living area. So you will be providing multiple features like this, and so this will be the final output, or we call it as a label. Now depends on the type of label that you have, whether it's a continuous variable or whether it's a discrete variable. We can choose a specific algorithm here. So there is no one single algorithm for different data sets, different applications. So type of algorithm that you choose depends on your target variable. For example, here it's a continuous variable or a real value that we have. So there's a specific algorithm that is used. Now, say one thing is the data. Of course, the machine learning requires lots of data. Second thing, the algorithm that you choose, the algorithm, which is a return to learn from the data. The type of algorithm depends on the application. For example, if it's a house price prediction, your target variable will be a continuous value. Okay, so between a minimum and maximum. So you need to go for a specific algorithm in this case. Whereas if it is something different, for example, some cases your output variable will have only two values. If it's about predicting whether the patient has a malignant cancer or not, so their output can have only two values, either 0 or 1. So in such cases you will have to go for a different algorithm. So there are two important algorithms that are being discussed in machine learning. One is a regression and the second one classification. A regression is being used when output variable is a continuous variable like this in the case of house price prediction, whereas classification when you have a discrete variable, it may be a binary, or sometimes it may be it may have more than two classes also. Okay, in such cases you go for classification algorithm. Now if you look at this particular data set, and if this data set is provided to a machine learning model for training, so then we call this algorithm as a supervised algorithm. In supervised algorithm, we provide input features along with the output during the training process, and this is called a labeled data set or labeled data. When you say labeled data, label is nothing but the output variable. So we provide input, which are features. In this case there are two, in this case only one feature, and along with that during the training process you also provide the output variable, which is a label. So if labeled data like this is used for training, then that's called supervised learning. In the case of unsupervised learning, where label will not be provided, output variable will not be provided, only the features will be provided, and the algorithm will try to classify them into different classes. Example is given here. In this case, if you have to group them into different classes, so then you don't have to provide labels. So that there are different types of algorithms, depends on the use case. We may have to use regression, or we may have to use classification. Again, there is another type of classification based on what type of data set is used, whether it's a labeled data set or unlabeled data set, etc. So if you look at this particular slide, there are learning algorithms are classified into different classes. Supervised means labeled data is provided. Under that you can have regression or classification, depends on the type of output variable or label that you have. Unsupervised learning, where unlabeled data set is provided. That means the target variable will not be provided during the training time. There are even other classifications like reinforcement learning and deep learning. So these also are very important, and they are used for specific applications. So to move on, what we understood is Type of data to be used during training phase depends on the use case or depends on the application. So in some scenarios, in some examples or applications, text is being used, or in some cases the speech, if it is a speech to text conversion, then speech samples are being used. So your data set consists of speech samples. In some cases, if it is image classification or object detection, where image files are being used as a data set. So similarly, a type of data set depends on the application. So there is another setup, so there are JSON files are used, or tabular data like CSV files are also used as data set. Now, in this particular example, we look at one type of data set, that is structured data. The same is being used for house price prediction also. If you look at this particular data set, this is called as a structured data, which is in the tabular form or a spreadsheet form. So this is an example for structured data. And if you look at the file extension, which is comma separated value .csv file, so data set will be stored in this particular form. And if you look at this, this has got multiple features, and the last column is the target variable or output variable, or a label we can call. So this is also an example for structured data, which is a tabular form, which is in tabular form or .csv file. And if you look at this particular data set, this is the advertising data set. There are three features: the amount that has been spent for TV advertising, radio, newspaper advertising, and the output column is a sales, the expected sales. Okay, so that will be the output variable in this case. So here also regression algorithm is used because output variable is continuous variable. Now when you look at this particular data set, again this is a structured data because a tabular, this is in the tabular form or spreadsheet form. So this data set pertaining to healthcare, and you can see that there are multiple features that you have, and the last column is your output variable, which indicates whether the patient will have a risk of coronary heart disease or not. 0 means no risk, 1 means a risk involved. So if you look at the output variable, it is binary. So classification algorithm will be used in this case. But type of data set, again, it is structured data in the form of .csv file, and a labeled data set is provided. So supervised algorithm is used here. Now that is about the algorithm, and we also discussed about the type of data. But in order to write a program, in order to a program for training and performing prediction, we need certain tools. We need a programming interface. We also need some libraries. So Python is the recommended programming language. Already we discussed. I have several videos on the few videos, part 1 to part 7. So that is about some of the libraries as well as Python programming itself. So we will have a practical demonstration in the next video. So I kindly request you to watch that video after this one. So thank you so much.